let's talk about electrons, valence shells, and the octet rule. So this is some background knowledge that you'll need to know. So a stable atom will generally have the same amount of electrons as protons, right? So protons are positively charged and electrons are negatively charged. So you need the same amount of electrons and protons to remain balanced. And you also need to know about atomic numbers, right? So this number over here is the atomic number. That's how many protons are in an atom. So oxygen has 8 protons, and because a stable atom will generally have the same amount of electrons as protons, right? Since it has 8 protons, it will have 8 electrons. Right, so let's talk about electron shells. So the first electron shell will contain 2 electrons max. The second electron shell will contain 8 electrons max. The third electron shell will contain 18 electrons max. So it's going to follow the pattern of 2 times n squared, where the value n represents the electron shell number, right? So as you can see here, right, this is the nucleus. This is the first electron shell, it has 2 electrons. The second electron shell, it has 8 electrons, and then the third electron shell, which has a maximum of 18 electrons, but it only has 1 electron in this example. So what are valence shells, right? So valence shells are the outermost shell of an atom. So in this example, right, this outermost electron shell is going to be the valence shell. And electrons in the valence shell are called valence electrons. Another important thing to note is that electrons that are not in the valence shell are called core electrons. So these electrons in the middle, these electrons in the second electron shell, those are called core electrons. So now we need to talk about the octet rule. So atoms tend to prefer to have 8 electrons in the valence shell, unless the first shell is the valence shell, right? Then, because the first shell can only have a maximum of 2 electrons, right? It's called the duet rule, and the atoms prefer to have 2 electrons. When an atom fulfills this octet rule, or the duet rule, right, it is considered to have a full valence shell. So that doesn't necessarily mean it has the maximum amount of electrons required in that shell. Also note that there are exceptions to this rule. So let's take a look at this example, right? So in this atom, right, it has a full valence shell because it satisfies the octet rule, right? There's 8 electrons in the outermost shell. It still has a full valence shell even though it doesn't have the maximum number of electrons in its outermost shell, right? In the third shell, there is a maximum of 18 electrons, and this one only has 8. But because it satisfies the octet rule, it is considered a full valence shell. So the periodic table is going to be your best way of identifying how many valence electrons an atom has. So columns in the periodic table are called groups. So column 1, this one is called group 1. Column 2, this is called group 2. Column 3, group 3. Column 4, group 4, and so on, right? So the number of the group tells you how many valence electrons atoms of that group have. So in group 1, all of these atoms have 1 valence electron. So like, let's take the example of lithium, right? So let's say this is lithium's nucleus, right? Lithium has 3 protons, so that it's going to have 3 electrons, right? So that means it's going to have 2 shells, right? 2 electrons in the first shell, and then 1 electron in the second shell. So it has 1 valence electron. So it has 1 valence electron, and it's in group 1, right? So the group number corresponds to the number of valence electrons. So one thing to note, though, is that for groups 13, 14, 15, 16, 17, 18, this is very important. They're not all going to have 13 valence electrons, 14 valence electrons, 15 valence electrons, etc., right? We can instead think of them as group 3, 4, 5, 6, 7, and 8 for functional purposes if we're talking about valence electrons, right? So you're probably a little confused, right? You're probably thinking like, didn't he just say that the group corresponds to the number of valence electrons? Yes, but we should think of it like this for now because of electron configuration and orbitals. So I speak of electron configuration in a previous video. If you want to go to check that out, I'll add a link to it in the description. And orbitals is something I'll be talking about in another video. So basically what you really have to do is just get rid of the one in front of the number, right? So let's say we have group 3, 4, 5, 6, 7, 8 for functional purposes, right? So boron, right, it's going to have 3 valence electrons, right? Because it's in group 13. So you get rid of that 1, group 3, right? And that means it's going to have 3 valence electrons. So let's say this is boron's nucleus, right? It's going to be its first shell. This is going to be its second shell, right? It's going to have 2 electrons in the first shell. And boron has 5 protons, right? Its atomic number is 5. So that means that it's going to have 5 electrons total. So we need 3 more electrons. That means 3 electrons in the valence shell. If we're talking about a full valence shell, right, that means that the atom satisfies the octet rule. Atoms in group 18, or for functional purposes, group 8, those are going to have a full valence shell. Lastly, we could talk about helium. It's kind of an exception to what I was saying about the groups. What you need to know is that all the atoms in group 18, right, or if you get rid of the one group 8, they are noble gases. And all noble gases have a full valence shell. So for helium, it has 2 protons, right? Its atomic number is 2. So that means it has 2 electrons, and 2 electrons in the first shell satisfies the duet rule. So that means it has a full valence shell. So why is this important, right? Like, why does it matter how many electrons are in the valence shell? So because of the octet rule, or the duet rule, right, atoms will prefer to have 8 electrons in the valence shell, right? So because of that, atoms will form bonds with other atoms to gain more electrons or to lose electrons in order to get that full valence shell. And these bonds are extremely important to everything in chemistry. They essentially make up chemistry.